Welcome to my 69th tutoring session in A-level chemistry. In this video, I'll explain the index of hydrogen deficiency for organic compounds. By the end of this video, my viewers will learn as how to determine the number of double bonds, triple bonds or rings present in a molecule based on its molecular formula. What are hydrocarbons? Hydrocarbons are organic compounds that contain carbon-hydrogen covalent bond in their molecule. So basically hydrocarbons contain both carbon atom as well as hydrogen atom in their structure. Now hydrocarbons can be categorized into two types. The first class are acyclic or open chain compounds like alkanes, alkenes and alkynes. While the second class of compounds, they are cyclic and closed chain compounds like cycloalkanes and aromatic hydrocarbons. Now alkenes are saturated hydrocarbons and they are characterized by the presence of carbon-carbon single bond in their molecule. And the carbon atoms in alkenes, they are sp3 hybridized. Alkenes are unsaturated hydrocarbons characterized by the presence of carbon-carbon double bond in their molecule, where the carbon atoms are sp2 hybridized. While alkynes, they are highly unsaturated hydrocarbons and they are characterized by the presence of carbon-carbon triple bond in their molecule. And the carbon atoms in case of alkynes, they are sp hybridized. And moving on to the cyclic or closed chain compounds. Cycloalkanes contain carbon atoms that are sp3 hybridized, while carbon in case of aromatic hydrocarbons are sp2 hybridized. Why alkanes are named as saturated hydrocarbons? The reason is the carbon skeleton in case of alkanes, they are completely saturated with hydrogen atoms and hence the name saturated hydrocarbons. And alkanes have the general formula CnH2n plus 2. While alkenes that are unsaturated hydrocarbons have the general formula CnH2n. Now when you compare and contrast the general formulas of alkenes and alkanes, you will find that the general formula in case of alkenes does not contain plus 2. That is because the alkenes, they contain 2 hydrogen atoms less than the corresponding alkene. Like for example, ethylene is an alkene. It contains 2 hydrogen atoms less than the corresponding alkane, ethane. So ethane is the corresponding alkane for ethene. So alkenes in general, they contain 2 hydrogen atoms less than the corresponding alkanes. Likewise, in case of cycloalkanes, even they have the general formula CnH2n. While alkynes that are highly unsaturated hydrocarbons, they have the general formula CnH2n minus 2. Now, when you compare and contrast the structure of ethyne, which is an alkyne, to that of ethane, which is an alkane, you will find that ethyne, it contains 4 hydrogen atoms less than the corresponding alkane, ethane. So what you learned from comparing and contrasting the molecular formulas of alkanes, alkenes, cycloalkanes and alkynes? So we learned that alkenes, cycloalkanes and alkynes, they contain fewer hydrogen atoms than alkanes. So presence of double bond, triple bond or a ring causes hydrogen deficiency. So the key takeaway is that alkenes, alkynes, cycloalkanes and aromatic hydrocarbons, they contain fewer hydrogen atoms than alkanes. And what is causing the hydrogen deficiency? The presence of double bond, triple bond or a ring causes hydrogen deficiency. So whenever you come across a structure with double bond, you can say the molecule has hydrogen deficiency. And whenever you come across a structure with a triple bond or a ring, you can conclude that these structures have hydrogen deficiency. Now, so much for the introduction about the hydrogen deficiency. Now, talking about the index of hydrogen deficiency. Now, what does the index of hydrogen deficiency explain about? Now, the index of hydrogen deficiency, abbreviated as IHD. Now, henceforth, I'll be using the using the abbreviation IHD. Now, IHD is also known as the degree of unsaturation. And it is a tool used in organic chemistry to determine the number of double bonds, triple bonds or rings present in a molecule. And overall, ISD helps identify structural elements of a compound based on its molecular formula. So one can identify the presence of a ring structure, presence of double bond or triple bond based on index of hydrogen deficiency value. Now here's the formula for calculating the ISD, where C represents the number of carbon atoms, H is the number of hydrogen atoms, N stands for the number of nitrogen atoms, and X represents the number of halogen atoms present in the given molecule. So only the molecular formula will be given, or the structure. So each degree of unsaturation corresponds to either the presence of one ring in the structure, or the presence of one double bond in the structure, or presence of one triple bond in the structure. Now in case of a triple bond, it is generally considered as 2 degrees of unsaturation, because triple bond, it contains 2 pi bonds, and therefore a triple bond is considered as 2 degrees of unsaturation. So overall, when organic chemists ascertain the molecular formula and the hydrogen deficiency index of an unknown compound, they can identify the structural elements of a compound based on its molecular formula. So the ISD reveals the or gives a detailed insight about the structural characteristics for the given molecular formula. So here's the step-by-step method for the ISD index. Step 1, you have to identify the molecular formula for the compound. Substitute the values of carbon, hydrogen, nitrogen and halogen into the formula. Calculate the ISD and finally interpret the result. Now the interpretation for the result is based on the ISD values. If the ISD value is 0, you can conclude that there are no rings or double bonds in the structure. For example, alkenes. If the ISD value is 1, it explains the presence of one ring or one double bond in the structure. When the ISD value is 2, it explains the presence of 2 double bonds, one triple bond or one ring and one double bond in the structure. So the structural details can be presumed based on the ISD values. Now time for some practice problems. First example, let's take a molecular formula C3H6. So substituting these values into the formula, you get a ISD value of 1. And how do you interpret this? So whenever you get IHD value of 1, it means that the molecule has 1 degree of unsaturation, which means that the molecule could have one double bond, like in case of propene, or it could be a ring compound, presence of one ring, as in case of cyclopropane. So both propene and cyclopropane, they have the same molecular formula. So it could be either one of these two structures. And further, the structural conformation can be done based on spectral characterization. That is based on spectroscopy methods. The second example, C6H6 is the molecular formula. Substituting into the formula, you get an IHD value of 4. Interpretation will be, since you got IHD value of 4, the molecule has 4 degrees of unsaturation. For example, it could be benzene. The benzene ring satisfies this IHD value of 4 because it has 1 ring and 3 double bonds, totally accounting for IHD value of 4. So benzene ring, it has 1 ring and has 3 double bonds in the aromatic ring. Third example, C4H8Cl2. Now there are 2 chlorine atoms in this molecule. Substituting into the formula, you get IHD value of 0. And whenever you end up with a value of 0, the interpretation will be the molecule has no degrees of unsaturation. There will be no unsaturation. So it is a fully saturated compound. For example, it could be 1,2-dichlorobutane. Now structural elucidation can be carried out using a spectral studies like UV, IR, NMR and mass spectroscope. Next example, C5H9N. Substituting into the formula, you get a IHD value of 2. So the molecule can have 2 degrees of unsaturation, meaning it could have 2 double bonds, or it could have 1 triple bond, or it can also have 1 ring and 1 double bond. So you cannot say for sure which one of these 3 can be ascertained to the particular given structure. So it could be any one of these 3. So cyclopropane with molecular formula C3H6, it has a IHD value of 1, accounting for presence of 1 ring. C5H6 for cyclopentadiene, it has IHD value of 3 because it has 1 ring and 2 double bonds. Next is pyridine. Now pyridine ring, it has IHD value of 4, 1 ring, that is pyridine ring, and 3 double bonds. So pyridine ring is an aromatic ring characterized by the presence of 3 alternative double bonds. Next is cyclohexane ring, IHD value of 1 because it has 1 ring with no unsaturation. Next is cyclopentane, IHD value of 1, showing the presence of 1 ring. Now let us take up some compounds of medicinal interest, compounds of some therapeutic value. Now nicotine, molecular formula C10H14N2 with IHD value of 5. So you have 2 rings in nicotine. One is the pyridine ring, other is the pyrrolidine ring. Now the pyridine ring has 3 double bonds. So totally IHD value of 5. 2 rings, that is pyridine ring and pyrrolidine ring, 3 double bonds. That is 3 double bonds present in the aromatic pyridine ring. Next is morphine. Now, morphine is a narcotic analgesic with IHD value of 9. So totally there are 5 rings in the structure. And there are 4 double bonds. 3 double bonds from the benzene ring and 1 double bond from the fused cyclohexene ring. The next is the classical painkiller paracetamol with IHD value of 5. So how do you account for the IHD value of 5 in case of paracetamol? You see presence of 1 ring, aromatic ring, and 4 double bonds. 3 double bonds from the benzene ring and 1 double bond present in the carbonyl group. And the antitubercular drug isoniazid with an IHD value of 5. It has 1 ring, that is pyridine ring, and you see the presence of 4 double bonds. 3 double bonds in the aromatic pyridine ring and 1 site of unsaturation in the carbonyl group, that is CO group. And next is vitamin C or ascorbic acid. It has an IHD value of 3. The value of 3 is accounted for 1 ring, that is furon ring, and presence of 2 double bonds. 1 double bond is present in the furon ring and the other double bond is present as a carbonyl group attached to the second carbon of the furon ring. Now when the index of hydrogen deficiency value is 3, definitely the molecule has 3 degrees of unsaturation, and this could correspond to combination of rings, double bonds, or a triple bond in the molecule. So let's explore some examples to illustrate this. So 135 hexatriene molecule with 3 double bonds, like in case of benzene. And second example will be a molecule with 1 ring and 2 double bonds. So in case of first example, that is 135 hexatriene, you find the alternative arrangement of 3 double bonds. There are 3 sites of unsaturation or 3 degrees of unsaturation. Now this 3 degrees of unsaturation can be found even in case of benzene. So both benzene and 135 hexatriene, they are one and the same. I mean the molecular formula C6H6. So structural confirmation can be done only by spectral studies. And second example is molecule with 1 ring and 2 double bonds, like in case of 1,3-cyclohexadiene. Substituting the value into the formula, you get a IHD value of 3. So interpretation will be the molecule has 3 degrees of unsaturation. So this is a possible structure, that is a ring with 2 double bonds. So it could be 1,3-cyclohexadiene. Now a molecule with 1 triple bond and 1 double bond. Molecular formula C4H4, IHD value of 3. So a molecule with IHD value of 3, it should have 3 degrees of unsaturation. So possible structure is a triple bond and a double bond. So it could be a compound like vinyl acetylene. The other names for vinyl acetylene is 1-butene, 3-ine, or butenine. So when you observe the structure of vinyl acetylene, you find the presence of a double bond and triple bond. So a double bond accounts for 1 degree of unsaturation, while a triple bond accounts for 2 degrees of unsaturation. Remember, a triple bond is constituted by 2 pi bonds and therefore 2 degrees of unsaturation. And molecule with 3 rings, for example, let's say the molecular formula is C14H10. That is a given molecular formula. So after calculating the IHD value, you end up with 10. So IHD is 10. It accounts for 3 rings with 7 double bonds. Like it could be an anthracene structure or it could be phenanthrene. So it could be any of these 2 structures. It could be either anthracene or phenanthrene. So both the structures have the same molecular formula C14H10. Both have 3 rings with 7 double bonds. Thank you so much for watching my video. I hope you enjoyed it, and I'll meet you in my next interesting tutoring session.